Okay, we are going to review a couple things on functions and one-to-one functions. If I have a domain and a range, and we'll call this function f, how do you tell if f is a function? Every domain is attached to only one range. So, is that a function? Yes. That's not a problem. What about this? Is that a function? Every domain only hits one range, so yes, that's okay. But if I do this, that is not a function because this domain goes to two different ranges. And essentially what it means is, if you plug in the number 7 into a function, are you always going to get the same answer? Yes. X equals 7 only has one output attached to it. So that's function. What about one-to-one? And we write one-to-one like this. So one-to-one is sort of the opposite of function. Every range only hits one domain. So is that one-to-one? This is a one-to-one relation. It fails the function definition, but it is one-to-one. So this would be a one-to-one relation. Well, we don't ever, it's not a function, so we would probably just cut it out. All right, what about this? Oh, wait, that's what I just did. I'll get this right. Is that a function? Yes. Is it one-to-one? No, because there are two elements in the range that go to the same domain. Or, yeah, there's an element of the range that go to two different domains. So in order to be one-to-one, it's got to look like this. Every domain has one range and every range has one domain. Now, I could mix it up. That's still a one-to-one function. And if you notice, the number of elements in the domain and the number of elements in the range have to be the same size if it's a one-to-one function. So, look at page... look at page 208. Oh, you can't see this. So I have three functions listed by points. We need to determine whether they're a relation, a function, or a one-to-one function. Is f a function? No. Because 1 goes to 2 and 1 goes to 3. So 1 goes to both 2 and to 3, so it's not a function. Is g a function? We have 2 and 0 and 3, so we have three different domains, three different elements of the domain. Is g one-to-one? No, because when I turn that around, it's not a function. So that's, if you invert a non-one-to-one function, you get something that's not a function. And then h, is h a function? Yes, we have three different domains. Is h one-to-one? Yes, it has three different ranges, and you see an example of those right here. So f is not a function because of that. G is not one-to-one because of that. But h is a function and one-to-one. So what about graphically? How do you tell if a graph is a function? So if I had that, you test whether it's a function using the vertical line test. Does this ever hit more than once? No. What if the graph stops right there? Does this have to hit the graph over here? No. The rule is it can't hit more than once. It doesn't have to hit once. It can hit 0 times over here. So there is no spot on this graph where this line hits twice. How do you tell if something is 1-to-1? You change this. Oh, maybe it won't let me. You change this to a horizontal line, and then you test this way. Is this 1-to-1? No. Now, the reason that 1-to-1 is so important, if a relation is a function, that means it's really useful, it's reliable. You plug in a number and you get the same number out every time. And if it's 1-to-1, you can invert it and still get a function. So if I tried to invert this, so if I reflect it across the y equals x line, it's going to look something like this. Let me get rid of the original. So the new one, I didn't do a very good job. Yeah, sorry. So this new graph actually fails the horizontal line test, but I did a terrible job of drawing that. So let's do it this way. If I had this graph, it's a function, but it's not 1-to-1. If you invert that, you get this. And now it fails the vertical line test. But if you have a function that is 1-to-1, like x to the third, if I invert that graph, I get this. Does that green graph pass the vertical line test? Yes. So 1-to-1 functions are invertible, and they preserve functionality. So you're working on page 219, 1 through 18 all, and you're going to be looking at a series of points. 1 through 4, you're just looking at points. Determine whether the given function relation is a function. If it is a function, determine whether or not it's 1-to-1. And then 5 through 10, you're going to just look at the graphs. What about 11 through 18? How do you tell if the equation is a function? Well, all of these are functions. How do we know? If you have f of x and then you have x's on the other side of the equal sign, it has to be a function. The only time you run into non-functions is where you have like y squared or other y to the third, y to the fourth. Those could be non-functions. So what you're determining on 11 through 18 is this 1-to-1? So you could graph it. It says find out algebraically and graphically. So you can graph this on your calculator and then do a horizontal line test. How do you tell if it's a function algebraically? Well, it has to be a function. If you have f of x equals, and then you have nothing but x's over here, that is a function. There's no way to not be a function if you set it up this way. So what it wants to know is, if you have y equals x squared, how do you tell if it's 1-to-1 without graphing it? Okay, so go to page 210. Example 3. Determining algebraically whether a function is 1-to-1. So determine algebraically whether the functions are 1-to-1. So it says find f of x sub 1 and f of x sub 2. And then it wants to know, or let f of x sub 1 equal f of x sub 2. Add 2 to both sides of the equation. Sorry. So you're going to plug in f of x sub 1. You're just plugging in an unknown x. And then you're going to plug in another unknown x. And then you're setting those two equal to each other. So we plug in x sub 1, and we get into this equation. So 5x to the third sub 1 minus 2, and this one, set them equal to each other. So 5x to the third sub 1 equals 5x sub 2, 3. Divide out the 5's, and I end up with this. Take the third root, and I get the first x equals the second x. Now that might seem weird. We just plugged in x sub 1 and x sub 2, and they equal each other, so it is 1 to 1. And that graph looks like this. So yes, it's 1 to 1, but this one is not. So we're going to do the same thing here. Plug in x sub 1 and x sub 2, and we get this equals this. Some absolute value equals another absolute value. So whenever you have an absolute value, the stuff in the middle could be positive, or the stuff in the middle could be negative. So we have the stuff in the middle equals the stuff on the other side, and the stuff in the middle equals the opposite of the stuff on the other side. The one on the left turns down to this, but the one on the right is not. So this second answer is not the same as the first answer, so it's not 1 to 1. Let's do an easier one. F of x equals x squared. So I'm going to plug in x sub 1. X sub 1 to the second equals, I'm going to plug in x sub 2. X sub 2 to the second. Now, how do I solve this? Square root, but if I square root this side, I have to square root the other side, and one or the other gets a plus or a minus. So I get x sub 1 equals plus or minus x sub 2. The first one is right. X sub 1 equals x sub 2. That's true. That's what we want. But that second version, that's the problem. And it's basically going to come down to either a square root or an x squared, which you square root, or an absolute value. That's how you're going to figure it out. Does that make sense? So all x squareds are not going to be 1 to 1, and all absolute values are not going to be 1 to 1. So we really don't even need to do all this work. You can just, if I go back to page 220, if you know the shapes of these graphs, then you can algebraically say, oh, wait a minute. This is going to give me a plus or minus. So algebraically, it's not 1 to 1. But you would have to graph it and say, oh, fails the horizontal line test there, and then point out what it is in the equation that makes it not 1 to 1. Okay, so I'm not going to make you go through and plug in x sub 1 and x sub 2. Just identify the part of the equation that makes it not 1 to 1. Okay? All right. Good luck.